Okay, your financial management module starts off with percentages. This is a typical percentage problem you're going to find in stores. So discounting their items. So example number 10, during a holiday sale, all items are discounted by 30%. Megan arrives and finds there's a sign that says take an additional 20%. So it's kind of a good, clever marketing scheme. Makes the customers feel really good about what they're paying. If you stop and do the math, it does not mean that everything is half off, but it leads you to believe that they are half off. So it makes the customer feel good about spending money. Okay, so what kind of deal really is going on? And you need to think, so discount, you need to think in terms of what you are going to pay. You've got to figure this out first to truly find the discount. Do not try and find the discount first. That's a headache. So try and figure out what you're going to pay. So for example, if it is marked down 30% off, you are going to pay 70% of the item, whatever the cost is. Since I don't know what it is, let's call it X. And the cost is really irrelevant. So you have to figure out what you're going to pay. So if it's 30% off, you're paying for 70% of it, and of is times. So if you transform this into math, it is going to be 0.7 times X. Okay, and then you are going to take an additional 20% off of that. So that means, don't think of discount, think of what you're going to pay. You are going to pay 80% of that. And if you transform that into math, it is going to be 0.8. We'll use this for times 0.7 of X. Okay, now, so if you do this, if you do 0.8 times 0.7, you are going to end up 0.56 times X. Okay, that means you are going to pay for 56% of the original tag. That means your discount is actually 100% minus 56%. Your discount is 44%. So it's a clever way for them to make you feel like you're getting half off, but you're really only getting 44% off. Okay, so always try to figure out in terms of how much you're going to pay first. So if the regular price of the sweater is 84 bucks, how much are you going to pay for it? She's going to pay 56% of it, so it's going to be 0.56 times 84, and they're going to ring her up at 47 bucks and 04 cents. In general, what is the actual discount of an item? Twice discounted this way. So again, this is what we did that in A. So you are going to think in terms of what you're going to pay, and you have to start with the original discount first. So the original was 30% off, so you're going to pay 70% of X, and then after you have paid, so that's your first move, times your X by 70%, and then take your second discount, and if it's 20%, you are paying 80%. And then if there were a third, then it said then take an additional 10% off of that latest discounted price, and you just keep going. So you start with the original, you do that first, and then all subsequent discounts you times. And this will give you, you're going to pay 56% of X. That means, and now once you know what you're paying, then find the discount. So your discount's going to be 44%. Okay, next one. The price of gasoline increased 20% within 1 quarter and then decreased. So it's going up and then it's going down. Okay, find the overall change. So what happened after the end of those 2 quarters? Alright, here's what's happening. So it's going to increase 20%. that means your cost, whatever it is, we don't know what it is, but you are going to find 120% of the original price. So if it's going up 20%, we're gonna do this shortcut. It's really similar to this. So if it's 30% off, you're paying for 70%. Because I don't want to find 30% of it and then add that back to the, or subtract that from the total. We want just one step. So I don't want to times the cost by 20% and then add that back to the original cost. So instead of doing that, I'm going to times it by 120%. So 120% of the original price. Then it's going to decrease by 8%, and that decrease means you are next, you are going to find, if it decreased by 8, you are going to find 92% of whatever that number is. So first you got to increase it by 120%. Then if it's going to decrease by 8, you are going to find 92% of it. And that represents an 8% decrease. So if you times this, the math is going to be 0.92 of is times 1.2 of whatever the original cost was. And 0.92 times 0.12, that is, let's see, what is that? It's like 110%. 0.92 times 1.2, that is 1.104 times x. Okay, now that means it's an increase. So we increased, so this one is, if I change it to a decimal, it's 110.4%. But I am really not interested in the 100%. I'm interested in this. So that is a 10.4% increase overall. Okay, 10 years ago I took a job with Rocky Road Investment Company. The first year I received a 10% raise. Then the next year I endured a 10% cut. And this cycle happened 5 times. My present salary is much lower than my initial salary. Why is that? Shouldn't they all balance out? Okay, so let's look at the math. The math says this is your present salary, X. Now if you are going to get a 10% raise, I am going to times that. I need to find 110% of my salary. So if my salary was 100 grand and I got a 10% raise, so I'm going to find 10% of 100 grand. 10% raise is pretty sweet. And if you do that, 10% of 100 grand is going to be 10 grand. But then you're going to have to add that back to your original salary. So your current salary for the next year is going to be 110 grand. Okay, now I get that same number if I times it by 100%. So the 100% is doing this addition for me. It's going to add my original salary to the new raise. So instead of finding 10% and adding it in, I'm just going to times it by 110%. Okay, and then after you receive that 10% raise, you're going to get a 10% cut. So now, here's what we got to do. We have got to find 90% of this. And this is the cycle. I get a 10% raise and then a 10% cut. So if I do the math here, it's 0.9 times 1.1 times x. So if I go 0.9 times 1.1, that is giving me actually 99% of my original salary. So after that cycle, I am making less than what they originally gave me when they hired me. Okay, now I'm going to do this 5 times. So that's once. Then they're going to give me they're going to give me a 10% raise, so I'm going to times it by 110%. Whoa. And then I'm going to times that by 90%. Then I'm going to times that by 110%. Then I'm going to times that by 90%. So I keep going over and over and over. So repeated multiplication is the same thing as an exponent. So I'm going to keep getting this 99%. So I'm going to do 0.99 to the 5th power. I'm going to cycle through that 5 times. So if we go 0.99 to the 5th power, well, whoops, 0.99 to the 5th is actually 0.9509. So now I am at 95% of my original salary. So that's 10% raise is nice, but then you're getting a 10% cut, not off of your original salary, but you're getting your 10% cut off of the raise included, which is more money off. So if they keep doing that, that's bad for you. You're going to end up losing money. Okay, example 14. 3 years ago, you bought a brand new Honda Accord and you paid 21 grand 500. Now you're ready to change your car. The car dealer tells you that it's worth 13 grand. Find the absolute and the relative change. Okay, the absolute change is pretty easy. The absolute change is going to be the new minus the original. So the new is 13 grand. Subtract the original, that's 21.5, and it is going to end up being a negative. And what is it? A negative 8 grand 500. Let's check that. 21.5 minus 13. Okay, so negative indicates that you lost, it's going down. Okay, now the relative change. The relative change is going to be your absolute change. So that negative 8,500 divided by the original. So divided by the 21.5. So really this whole module is just finding the right formula. It's all just plug and chug. So you find the formula from here on out especially. So this is the first formula that shows up. Your absolute change, your relative change. Okay, now your relative change is always going to be represented by a percent. So if you divide that, what do we end up with? We end up with, man, okay, we're going to end up with a negative 0.3953488. So that means it is a negative 39.5% change. So the negative means you lost. So it's worth less now than it was when it started. Okay, interest. Now there's three formulas: simple interest, compound interest, and continuous compound interest. So example 4, for your 10th birthday, grandparents give you 10 grand. You immediately invested this gift into an account that yields an APR of 4%. Today is your 25th birthday. How much do you have in your account? So they mentioned nothing of compounding. So this is going to be a simple interest. Your simple interest is the principal times 1 plus the rate, the APR, times how many years you leave it in. So 10 grand is going to be my principal. 1 plus the rate is 0.04. Times that by how many years? 25. You got it on your 10th birthday, so that is a difference of 15 years. So if you go 10 grand, blah, 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 you are going to end up in the bank with 16 grand. Okay, when you're in college, you learned about compound interest. How much money would you have had in your account if you had elected to invest your 10 grand into an account that pays 4% compounded monthly? Okay, now that's a whole different formula. So your compound formula, the amount of money in the bank is going to be P times 1 plus the rate divided by N times T for your exponents. So if you plug everything in, we're going to go 10 grand times 1 plus the rate is 0.04 over, you're going to compound monthly. That bank's going to give you interest 12 times a year. 12 times 15 is your exponent. So if you punch that in, you earn 18 grand, 203 and 2 cents. So 2 grand, 2,200 bucks more for nothing. And that is, I mean, 15 years. It's kind of a short period of time. If you really let it ride, the difference magnifies. Okay, example 5. Jane plans to make an investment into an account. APR of 3.75%. It's going to compound quarterly. In 5 years, she'd like to have enough money to buy a car for 25 grand. So how much should she invest right now into the bank? So that's the P. So I know the A is 25 grand. We're not sure what the P is, but it is a compound. We're compounding quarterly, so I'm going to use my compound formula. 1 plus the rate, 0.0375 divided by 4, because the bank's going to pay me 4 times a year. It's going to add interest to my principal. And your exponent is going to be 4 times, she's going to leave it in there for 5 years. Okay, so now I need to solve for P. So I am going to type this whole thing into my calculator, and that's going to simplify to be some number. So now it's just a linear equation. You have P times whatever that is. Then if we do that, we are going to get 1 plus 0.0375 divided by 4 raised to the 20th power, and that is 1.2051777, blah blah blah. So divide by that number, and 25 grand divided by that number will give you the principal. The principal is, she should invest originally 20 grand, 743 and 84 cents, and then over that 5 years she'll earn the 1,300 bucks she needs to buy the car. Okay, number 3. Suppose Trevor invests in an account that has an APR of 3.75 compounded continuously. Trevor decides that it will be a one-time deposit. He will not touch it for 8 years. Then his balance is going to be 12 grand 300. How much did he originally invest? So it's the same question as number 5, but if it is continuously compounding, that formula is A equals P times E to the RT. So here we go. We know that A, your end result is 12 grand 300. You do not know the initial deposit, so that's unknown. E, the rate is 0.0375, and he's going to let that ride for 8 years. So same as before, most of the time we're trying to find time, and to do that, that requires a log. But now this is really just once you change that to a number, it's just a linear equation, so it's a piece of cake. So on your calculator, you need to type in e to the 0.0375 times 8 and let the calculator do all the work, and it will change it to some number. That number is P times 1.349 blah 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 equals 12 grand 300. So now to solve for P, you just need to undo the multiplication. So divide by that number, divide by that number. The principal he's got to give the bank is, that initial investment was 9 grand 112 and about 6 cents ish. Okay, now let's look at one where we're probably going to have to find a log. Okay, Mark wants to invest $3,500 in an account, 6.2 APR, compounding monthly. He would like to rack up, he wants to build it to 5 grand. And he's putting in 3,500, so he wants 1,500 bucks. So how long is it going to take for this to happen? So here we go. He's going to end up with 5 grand. He put in 3,500 times 1 plus the rate 0.062 divided by 12 raised to the 12 times the time, and that's what we don't know. So now you gotta ditch the 12, you gotta ditch the parentheses. First you're gonna undo this 3,500. So 3,500 is timesing the parentheses, so undo the times. Divide by 3,500, divide this by 3,500. Okay, you're gonna get 10 sevenths equals. Now change this to a number. So if you go 1 plus 0.062 divided by 12, that is some number. I'm going to store that in my calculator, and I'm going to call that A to the 12t. Okay, now from here, it's a log, and you are going to transform this exponential equation into a logarithmic equation. So there are 3 components. There's this guy, there's this guy, and there's this guy. This is the exponent, this is the base, and really all you need to know are these 2. So if you transform this exponential equation to a logarithmic equation, we're going to go log, this is the base, and you read it, log in base A. Now A represents this decimal here, which is crappy. Log in base A, and logarithmic equations always equal the decimal, so it's going to be 12t. So that means I've got to put the 10 sevenths here. So it's log in base A of 10 sevenths equals 12t. Your calculator will transform this to a number. So then you have to solve for t. You just undo the times, divide by 12, divide that by 12. You should end up t is approximately, so let's use the tildes, it's approximately 5.767 years. Okay, so it's going to take 5 3/4 of a year. So question B, would it make a big difference if the interest was compounded continuously versus compounded monthly? So continuously is always a better deal than monthly, but this is really a short window. So investments are intended to be a 35-year deal. So 5-year investment, you're probably not going to see much difference, but you would always rather have the bank pay you interest every second of every day instead of just once a month. So continuously is going to be a way better deal, but really not in the short run. It's the long haul that it's the big deal. So let's do the math. Alright, compounding continuously. So we're going to take that end result, 5 grand. The initial was 3,500 times E to the 0.062 times T. Okay, undo the 35 grand, divide that by 3,500, divide that by 3,500, and we got 10/7 equals E to the 0.062 T. Okay, now you just log it. So it's going to be log in base E of 10/7 equals 0.062 T. Solve for T. Divide that number by 0.062. Whatever that number is, do that first on your calculator. Then divide that by 0.062. And the time is approximately 5.7528 years versus compounding monthly was like 5.76767 years. So really no difference, not much of a difference at all, just a few days difference. And that is because of the short turnaround. If it is only a 5-year investment, that is really too short to really start seeing the effects of the different compounding periods. Okay, let's look at the next one. Mike's savings account earns an APR of 4.15% compounded monthly. Sarah's earns an APR of 4.2% compounded quarterly, and this actually comes from APY. So the annual percentage yield, and that is really what you're interested in. What is your annual yield? If you're getting 4.15% compounded monthly, now if it's compounding, that does not mean you're getting 4.15% a year on your money, because they're going to pay you interest every month. That interest goes to your principal, and then you're earning more interest on your interest. So your APY is actually going to be higher than your APR. So anytime you're compounding, your APY is always higher than your APR, and that is excellent if you're earning money, but if you are paying debt, that sucks. Alright, so here we go. Who's earning more interest? So let's find the APY. So you look through your notes, you find the formula for APY. APY is, and you don't have to have these memorized, you got them all on your note card. APY is 1 plus R over N raised to the N minus 1. Okay, here we go. So let's do Mike's. And we'll do Sarah's over here. Okay, Mike has an APR of 4.15%, so Mike is this 1 plus 0.0415 divided by, he's compounded monthly, so N is 12 raised to the 12 minus 1. Sarah is 1 plus, her rate, okay, his rate is 4.15, hers is 4.2, so the rates are really close. 0.042. Hers is compounding less, so hers is compounding 4 times a year. to the 4 minus 1. So your gut would say Mike is the man you want to go. He's getting a slightly lower interest rate, but it's compounding more frequently. So my gut would tell me to go with this one first, but if you do the math, I think it's actually Sarah. And it's really neck and neck. It's pretty close. Okay, where are we? Mike, his APY, his annual yield, is going to be 4.22985%. Sarah's is 4.2666%. So it's to the hundredths. In the hundredths place, his is 2, hers is a 6. This is better. You always go with the higher APY, no matter how slight the difference is, because this hundredths, the difference in the hundredths place, I mean, maybe it means pennies at first, but at the end it's going to mean dollars. And you always want to chase more dollars. Okay, so Sarah's got the better deal. She's going to make more money. Alright, B. If they both make a one-time deposit of $4,500, how much will they each have in their account years later? So we're kind of anticipating Sarah's going to have more. Okay, so let's do Mike's. So Mike is going to have 4,500 times 1 plus the rate 0.0415. He's compounding monthly 12. Okay, how many? We're leaving it in for 8 years, so 12 times 8. Sarah's formula is going to be similar. It's going to be $4,500 times 1 plus her rate is 0.042 over 4 raised to the 4 times 8. Okay, if you crunch those numbers, Mike is going to walk away with, Mike's going to have 6,268.30 cents. Sarah is going to have 6,286.0 cents. So that slight difference over 8 years, she's got $268, or Mike does, and she has 286. So like $18 more, which might not be much, but I mean every little bit helps. Okay, I'm not going to do C. You can do C on your own. C is the exact same as B. All they do is change 4,500 to 5 grand, and they extend the 8-year investment to a 10-year investment. So exact same. You're going to end up with more money though, and Sarah will still have more money, but it's going to be a little bit more of a gain than the $18, because the more time goes on, the bigger that difference is going to get exaggerated. Okay, annuities. Now annuities, you just go to your section with annuities, find you've got an annuities formula. So here we go. Your IRA pays an APR 2.5% compounded monthly. So an annuity, this is real life, because you're going to be investing with regular installments. You're not just going to drop a one lump sum. So an annuity is regular installments. You're making monthly payments, you're making quarterly payments. You are continuously contributing to your investment. So that other stuff, the compound interest, all we've done so far is just a one lump sum, and that never happens unless you inherit some money. So annuities, that's how the rest of us do it. We contribute monthly. So we're going to contribute $140 a month for 13 years. How much will our IRA have at the end of that time? And even more important, how much interest did you earn? Okay, so here we go. Your formula is calculating a future value. So the future value is equal to, this formula is kind of intimidating. So it says future value. First we need capital R, and R is your regular payment. So I'm going to put a 140 there. Bracket, parenthesis, 1 plus the rate 0.025 over n, and compounding monthly, so that's 12, parenthesis, 12 times 12 times 13. Then I subtract 1, and then I close the bracket. And then on bottom, I'm going to put 0.025 divided by 12. Okay, now, first thing I would do is this. On your calculator, I'm going to type this 0.025 divided by 12, and I am going to store that as a variable. So hit the yellow button, store it as A. I just always store them as A. Oops, hit enter. Okay, now this is going to make things so much easier. You've got that stored in, so you don't need to scroll up and grab it. So that means this. I can erase this, and I can erase this, and I can just write A. Okay, now you just times them. Type this in exactly as it is on your calculator, and that will give you your future value. So type it in, hit enter, and your future value, which one, where are we? Whoa. Okay, the future value is going to end up being 25 grand, 775 and 42 cents. Okay, now here's the good question. How much interest did you earn? So the interest is the money made. So for 13 years, I contributed 140 bucks a month. So if I go 140 times 12 times 13, 140 times 12 times 13, 140 times 12 times 13, 2,100, no. Way more than that. 21,840. Okay, 21 grand of that 25 is mine. So if I take the 25 grand, which is the total in the bank, and I minus that 21 grand, I only made, let's see, hold on, I gotta type this in, 25,775.42, take away my return. I only made 3,935 bucks and 42 cents. So that's not a great return. That's a pretty good amount to be investing. Your rate though is way low, so that's like a bond or something super conservative, not risky, and they grow way slow. So that's a way low rate, so not much money, so that makes sense. Everything feels good. Okay, problem 6. This is actually probably the hardest problem, definitely the hardest on the whole review. So here's what's happening. You got a savings plan that pays 2.5% compounded monthly. So again, a way low rate. That's not very good at all. You make payments of 75 bucks at the end of each month for 15 years. And then you make monthly payments of 110 for an additional 6. Now this really is pretty typical. You're going to start off paying 50 bucks into an annuity, 75 bucks, but then as you kind of progress in your career and get a little more stable, you get your cost of living raises plus another percent, so you get an 8% a year raise, something. You're making more money, you're getting a little more secure, so you are going to begin investing more money into your annuity. So every few years you want to up that price by 30 bucks, 50 bucks. I mean, every little bit counts. So this is a pretty typical scenario. Now, here we go. We're going to have to do it in 3 parts. So let's do this first part. We are going to get a 2.5% return, compounded monthly, $75 payments. So our future value is this big fraction. So I'm going to go my monthly payment, which is 75 times 1 plus, okay, I'm just going to go A. And A is 0.025 divided by 12. So I'll store that in my calculator right now. Raised to the 12 times, I'm leaving this first one in for 15 years. Then I'm going to minus 1, close the bracket, and that is all over A. So let me crunch this out real quick. 0.025 divided by 12. Okay, here we go. I'm going to have, whoops. Alright. Okay, I'm going to end up with a total of 16 grand, 359 and 26 cents. 26.24.673. Okay, so that's how much money I got in the bank. Now I am going to change my monthly payment. I can afford more, so now I'm going to up it to 110. Okay, now this is part 1. Boom, 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 boom. So this money that I made, this 16 grand, it is going to continue to compound monthly at 2.5%. So here's what I'm going to do. I'm going to take that money, that's my principal. I am going to times that, let me get rid of this, by 1 plus the rate, the same rate, 0.025 over 12. And so this is like my one lump sum investment. So I'm going to use my just traditional compound interest formula. And how long are we going to leave it there? We're going to leave it in for 6 more years. So I got to go 12 times 6. So if I take that, leave it in the bank for 6 years, compounding monthly, I am going to have that times 1 plus 12 times 6. Okay, this is going to turn in to $19,003.79. If I just let that ride for the next 6 years. Okay, now I'm going to, on top of that, I am going to be making payments of 110 bucks. So now I got to find this. I've got to find the future value of my $110 payment. 1 plus A to the 12 times, instead of 15 years, I am going to do this for 6 years, minus 1, all over A. Okay, so now I gotta crunch this. So I'm putting in 110 bucks a month. And this is going to give me 8 grand. $535.28. Alright, so A, the value of that account at the end of those 21 years is going to be my 19 grand plus my 8 grand. If I add those together, I am going to walk away with $27,539.06. So question B is the good question. How much of that is mine and how much of that is money I made? So what's the interest? So my money is this. I paid 75 bucks a month, so times 12, for 15 years. Then I paid 110 bucks a month, so times that by 12, times that by 6 years. So 75 times 12 times 15, that is 13,500. Then 110 times 12 times 6, that is 7,920. So if I add those together, my money is 21,420. So if I subtract that, the difference is going to be like 6 grand. So $6,000 profit. So it does not seem like much. Again, the rate is way low. That's a pretty crappy rate. And really, this is what you want to do towards the end of your investing. You want to transfer all your mutual funds. You want to transfer it to a lower rate, a conservative rate. Because if you're going to be retiring in the next 5 years, you want to pull your investment out of that risky, aggressive rate, put it into something more conservative, more safe, like this, like bonds, like this low rate here. And then you're sure to kind of hedge your bets. You're going to protect your money, because when they're in that higher interest return, those are riskier investments. And so there's a chance maybe next year we go to war, things go south, then you lose tons of money. And if you're ready to retire, you do not want to be losing tons of money. But you can be losing tons of money in your 40s and your 50s, because it's going to rebound and bounce back. Okay, last one. Your amortization. You don't want to remodel your house, you need a loan for 100 grand. Your bank is offering a 15-year fixed rate with an APR of 4.5% compounded monthly. You get a second bid from a credit union, and they can offer you a 10-year fixed rate with APR of 4.25%. Which route are you going? Alright, here we go. So now you go to your amortization. There's a formula for that. And it looks pretty intimidating also. But this has a lot to do with your annuity formula. So here we go. Okay, so my monthly payment is going to be capital S, which is your loan amount. That's 100 grand. I got to borrow 100 grand. Times that by a crazy fraction. Okay, I'm going to call that A. A equals R over N. On the bottom, it's going to be 1 minus parentheses 1 plus A parentheses to the negative N. Well, let me put in something for N, I guess. And what are we doing? We're going monthly. So N is 12 times 15 year. I'm borrowing for 15 years. Ba-ching. Okay, I crunch that. I do the math, plug it in. Ba-boom, ba-boom, ba-boom. And my monthly payment is going to be $764.99. Okay, let's check the credit union. Credit union, same thing, 100 grand. Parentheses. Now this A is going to be a lower rate, so your APR is 4.25. So I'm going to still call that A, R over N. Divided by 1 minus 1 plus A to the negative 12 times. Okay, this is a 10-year fixed. So you do that math, crunch it up, and that is going to be $1,024. 37 cents, 38 cents. Okay, B is a good question. How much would your total payments be over the life of the loan? So that's actually easy. We don't need any spreadsheet. You just take your monthly payment, which is $764.99, and you are going to times that by, let's see, we're doing that, we're actually going to times that by 12 months every month. And you're going to do that for 15 years. So you got to times by 12, you got to times by 15. The amount of money you are going to pay is 137 grand 698 and 79 cents. Same thing here. Time this by 12, but then times it only by 10 years. And that's going to be 122,925.04. So your credit union is a lower rate. You're now 10-year fixed compared to a 15-year fixed. You're going to end up only paying 122 grand, 123 to borrow. This one you're going to have to pay almost 138. So how much interest are you going to pay? To make that loan happen, you are going to have to pay the bank $37,698.79. The credit union is $22,925.04 cents. So this one is way cheaper, but $765 a month compared to $1,025 is a lot more affordable in the budget. So the majority of Americans are going to go with this. The $764 payment is easier every month to make. They don't mind paying the extra interest overall, and the banks are making tons and tons of money. So you need to start a bank.